So guys, today in the previous chapters we did where I introduced like how we find out derivatives of exponential functions and logarithm. The only logarithm function talked about was rational, and you can find what is going on the derivatives of the logarithm of general logarithm functions. And I think it is going to be easier. But today, if we dive into that today, we will check out how to reduce trigonometric functions. So today we will be learning about differentiation trigonometric functions, a short trigonometric functions. Okay. So what is the first trigonometric function we have? First trigonometric function we have is sine of x. Usually there's theta inside of this sine function, but since we are with respect to x, we're going to be taking x inside the sine function. You can do sine theta as well, but then the reduction of this function would be d sine theta by d theta. This is the same thing. Both x and theta refer to the same variable. Okay, so that's not a big deal. So what is the reduction of this function? Function of x is sine of x. Derivative of this function is d sine theta over dx. Okay, and from the first rule of calculus, what I learned is this would become as limit h approaches 0, sine of x plus h minus sine of h over h. Okay, so and now we will just simply the trigonometric formulas have over here and do some algebraic manipulations. Sorry for my sound. Okay, actually what would this become? This would become as h, which is 0. We can rewrite sine of x plus h as sine of x times cosine of h plus sine of h times cosine of x minus this thing sine of h. Why you can do that? Because this is a trigonometric identity. That sine of a plus b is sine of a times cosine of b plus sine of b times cosine of b. Okay, this whole thing is going to be over h. Okay, then from this actually this would be sine of x. Still sorry about that. First we don't know calculus. We have found most is this already that this actually would be sine of x plus h. Okay, sorry about that. So from here, from this sin x and cosine of h, and this sin x, you can factor out sin x, and this would look like as limit h tends to 0, sin of x, what do we have remaining over here? cosine of h, cosine of h minus 1 plus sine of h, cosine of h, cosine of x over h. Okay. Now we can split this two. We can rewrite this as h tends to 0, sine of x times cosine of h minus 1 over h plus sine of h times cosine of x, and limit is going to be applied on this whole thing. H over here, limit is going to be applied on this whole thing, and we can then rewrite this as there's a identity of limit that says that the limit of two functions is the sum of the functions would be the sum of the limits of those functions. So what I'm basically saying is that this would be the same as limit of h tends to 0 of sine x times sine x and cosine of x plus cosine of h minus 1 over h plus limit of h equals to 0 of sine h times cosine of x over h. Okay, there's a identity of limit that I was going to do. These things are basically the same, and I can actually explain what is the logic behind this. Here, limit displays the thing of this is function as well. That the limit function is being applied to sum of these two quantities, which would be, when you think about it, would be the same as you would take the limits of these two functions separately and then sum them at the end. Okay, and here if you notice clearly, you notice that here sine of x as cosine of x, these two quantities themselves are not dependent on the value of h, because sine function has x instead of this and instead of 10. Over here, cosine function has x instead of it. X of obviously the value of x does not depend on the value of h, and the limit is only being applied to h. So only h whose value we are going to be rounding up we will just know that's how this works. So what does that mean is that we can take out sine of x outside, and that is as sine of x times limit of h tends to 0 of cosine of h minus 1 over h plus, we take out cosine of x from here, cosine of x times limit of h tends to 0 of sine h over h. Okay, now the reverse is passing this. And this would become, look at this carefully. You know that the value of h is very small, like 10 to the power minus 20 or minus 30 something like that. So what happens when the value of h gets to really close to 0? What is the value of cosine of h? Of cosine of what is the value of cosine of theta when theta is 0 degrees? It's 1, right? So since the value of h is very close to 0, so you can basically say that this cosine of h would become 1. Okay, and so this half of this half over here would become sine of x times definitely here the limit again, limit of h tends to 0 of 1 minus 1 over h. Now it does not matter what is the value of h. H is here. This over here we know that h is very close to 0, but not exactly 0. But the top section of the fraction we know that's 0 here because it's 1 minus 1. So this would become 0. And what would this become? What we have is the limit here, sine of h over h. So if you get a calculator, as scientific calculator to be precise, and to find out that what would be the value of sine of theta over theta. So theta is extremely small, like 10 to the power minus 20 or 10 to the power minus 30 or something like that. You find out that this would tend to 1. This would tend to 1 because sine 0 is 0, and since we are slightly larger than 0, so this would be like slightly larger. The value of sine h would be slightly larger than 0, and the quantity we are going to be dividing it by h, it too could be slightly larger than 0. That means this number would be very close to each other, and because of that, we can say that this would approach 0. This would basically become approach 1. So this will become 1. So this portion of the quantities we have here would become cosine of x times 1. Okay, this would just become cosine of x. Okay, so what does that mean? That means that the derivative of sine x with respect to x is cosine of x. Now I can go on and then we find out what is the derivative of cosine of x is, what is the derivative of tan of x is. But I think in mathematics, not all formulas should be memorized. Some formulas should be calculated by you guys as well, as learner here. And basically, it's the same thing. You just have to understand. You just need to have a over your algebraic manipulation skills, and you easily do it. Okay. So I'm giving you this task that before I release the next video about calculus, you have to find out what is the derivative of cosine of x with respect to x is, and what is the derivative of tan of x with respect to x is. And if you guys still somehow don't find that, then don't worry, I will definitely make a video on this one. So that was it for the video today, guys. Hope you enjoyed it and hope you learned something. So yeah, that's what done. Learning and keep learning.